Hi, we are Team 15 and our project's name is Analysis and Redesign of a Marshall MG15FX Guitar Amplifier. The team members are Zachary, Lugie, Swayam, Connor, and myself, Mario.
Learning how to play the guitar or bass is a popular hobby throughout the world. Although acoustic guitars have been around for centuries, it was only in the 1930s that the electric guitar was invented, which in its diverse lineup of variants would eventually become a symbol for several genres of music. One indispensable piece of equipment to play an electric guitar is the guitar amplifier, which creates a high-power replica of the single input from the guitar. This amplifier not only creates a louder sound, but also produces different effects, such as distortion and overdrive, which in turn create a unique sound that has become iconic in many musical genres. Besides the electronics housing and the speaker that produces the sound, these types of amplifiers also need to be sturdy and durable, given that they are often used in rough conditions like garages, basements, and outdoor venues. Sheet metal, wood, plastic, fabric, and even EDPM rubber are used in the construction of these sturdy devices.
Detailed 3D models won't be necessary for the scope of this project. We will mainly work with 2D sketches. If specific dimensions are necessary, we have an amp readily available to us for measuring and general referencing. After taking apart the amp, we identified all its components, materials, and fastening methods. Based on it, we created an explosion view sketch. In this slide, we can see the complete exploded view diagram of the amplifier. We found that it is constructed of various different materials, such as EPDM rubber, injection molded hard plastic, compressed wood sheets, formed sheet metal, ABS laminate, and grill cloth fabric. Here we have a detailed exploded view diagram of the electronics console. Even though we didn't dig into the intricacies of the power and signal circuitry, we were able to identify three main PCBs: the instrument signal processing PCB, the secondary audio input processing PCB, and the volume equalizer and effect controls PCB. All these components are mounted into a single sheet metal bracket, which we identified to be made using 20-gauge galvanized steel. We used this information later on to estimate materials cost.
The following two fishbone diagrams introduce the two assembly sequences of guitar amplifier respectively. The outside wood casing is the main frame of our product, so both sequences begin with this part. In the first sequence, we choose to load the speaker section into the wood casing first. The speaker section was made up of three parts, namely front, cover, speaker base, and speaker. The next thing to be inserted into the wood casing is the electric console section. This step of assembly begins with the mounting bracket and finishes with the power button. Having sealed the wood back cover, we then have to rig the exterior of the amplifier with some fixing and portable features. Rubber handle, for example, allows users to easily lift the amplifier, and corner guards, which plays a stabilizing role and protects the amplifier from being easily worn out. The final step of the assembly is to glue the brand logo onto the front cover. In our product, the most two important sections are the console section and the speaker section. The only difference between the first assembly sequence and the second one is the sequence in which the speaker and the console were assembled. The speaker section will be assembled after the assembly of the console section in the second sequence, and a comparison of two sequences will be shown in the sequence table in the next page. As is shown in the table, we use 5 different criterions to evaluate these two sequences. Since the only differences is the assembly sequences of the speaker section and the console section, we think the transferring and handling will have the same score in each sequence. In the first one, with the presence of the speaker base, the locating of the speaker can be determined accurately and simply. After installing the speaker, we can just load the console section into the remaining space. However, in the second sequence, The console section is installed first. It is hard to determine how many assembly tolerances need to be left between the console and the speaker to ensure that the speaker can easily fit into the wood casing. Second, since the bottom of the console was fixed to the speaker by a metal sheet and bolts, it would be difficult to load the speaker into the wood casing if the console was loaded first. Therefore, sequence 1 scores 3 in locating and drawing, while sequence 2 can only score 1 in these two categories. Since the sub-assembly test can be conducted before loading into the wood casing, and different sequences will not affect the difficulty of assembling in parallel in our product. The score of these two items are the same. Finally, the total score for sequence 1 is 13 and 9 for sequence 2, so we think sequence 1 would be a better assembly sequence.
The main function of our Marshall amp is to amplify the signal or sound from the guitar. To do this, it must first create sound. Once the sound is created, the amp can modify the signal from the guitar to change the volume or alter the signal to make it sound different. This brings us to assured dependability, which can be summed up by the protection of the users. The main way we can protect the users is to prevent electrocution. This can be done by enclosing exposed wires and insulating exposed leads. We are then brought to assure convenience, meaning it must be easy to use. Also, we have enhanced product, which are functions that raise the amp above expectations. Therefore, we have auxiliary input and a headphone jack. Finally, it must please senses. It should look good and sound good.
The function component mapping matrix displays the connection between components in each row and function in each column. This chart easily shows how and where each component satisfies the functions of the amplifier, and which components can satisfy multiple functions. As an example, the brand logo serves no purpose other than for aesthetic, while the console casing, which houses the electronic brains of this device, satisfies 4 of the amplifier's functions.
Here we show some details as to how we estimated materials cost in our BOM. There are various methods to produce pressed wood sheets and slabs, some of them being plywood, OSB, MDF, and particle board. Most of these are used as construction materials in kitchens and furniture in general. Looking at the amp's case material, it most closely resembles particle board. The retail price for a 1/2 inch and 2 feet by 4 feet sheet is $11.98. For the sake of simplicity, we estimate the cost of the casing using this as reference and calculating on a square inch sum basis. Using the square inch basis method described in the previous slide, we estimated the materials cost of all components made of wood particle board, ABS laminate, rail cloth, and galvanized steel sheet as shown in the BOM. For components made of using plastic injection molding, we considered a high capital investment for tooling while dividing it up by the larger possible production volume throughout the tooling life cycle. After adding everything up, we estimate the materials and manufacturing cost of this amp to be $84.22.
The primary and secondary customers of guitar amplifiers are the casual hobbyist or enthusiast and the experienced enthusiast or prosumers. While both are looking for similar functioning amplifiers, both groups have distinct desires for their devices. Somewhat inexperienced and first-time users that make up the primary customers desire cost-effectiveness and durability, as they are not really familiar with the more particular or specific features of the amplifier. Conversely, the secondary customers have the knowledge and insight of their amplifier, so they desire reliability and quality construction or feel of the amplifier. To this group of customers, branding image is also important.
Considering that the primary design is aimed at casual hobbyists and entry-level users in general, we removed many of what could be considered extra features when it comes to instrument signal processing, while also simplifying the amp's construction. Some of the cost reduction and simplification features are a printed-on brand logo as opposed to an injection molded one, a hardcover over the speaker as opposed to the grill cloth application, and a much simpler signal processing console. We removed the two overdrive channels, the mid-level equalizer channel, the chorus, phaser, flanger, and delay effects, the manual and auto tuner select, and thus all the corresponding PCB and circuitry. We also define a platform-level common set of components and features, such as a pressed wood casing, ABS laminate of the entire case, a PDM rubber feed, a 15-watt 8-inch speaker, instrument signal amplification with one clean and one distortion channel, and volume and gain controls.